This will be our fifth lab where we'll be experimenting with cam mechanisms. The main goal for this lab is to analyze the displacement profile for various cams with different followers. We'll start with what is cam mechanism and why it is important. If you remember, in lab 1 we studied 4-bar mechanism, linkages. So why cam? And then we'll identify different types of cams and followers. There's so many different types of way you can classify cams and followers, but we'll only focus the types that we're going to study in this experiment, not the entire pool of cams and follower types. Then we'll familiarize ourselves with the cam system terms that we use for cam mechanisms such as dwell, rise, and fall. And finally, we'll do the experiment with 4 different types of cam mechanism to construct displacement profile for those mechanisms. So let's start with discussing what is cam mechanism and why it is important. A cam follower mechanism is a profiled shape mounted on a shaft that drives the follower. On the image on your right, you can see a cam here, and it is on the foreside. So it has a profile, and it is driving, and the follower is this piston rod. So it's a profile shape mounted on a shaft. It is mounted on this shaft and drives the follower. It converts a rotary motion to a reciprocating linear motion. Again, you can see it is rotating and it is converting the rotary motion to linear motion. There is a little more into it. That's what we're going to see right now. That leads us actually the importance of cam mechanism, why it is important. So it can generate irregular motion. You see, this shape, this profile can be circular. Now it's a pure shape. It can be any shape that you want. That will affect the timing and the motion of the rod here, and that cannot be obtained from linkage that we have learned in previous labs. So that makes it unique and important for application in our engineering lab. So there is many type of classification possible for cams. So the types that we're gonna study based on their shape, and we're gonna study only 4 types of cams based on their shape. The first one is pure cam. It is called pure cam because the cam looks like a pear. And similarly, the next one called offset circular cam. It's a circular cam, you can see, and you see it is not rotating about its center but offset. That's why it's called offset circular cam. And obviously this looks like a heart, and this is why it's called heart cam. This one we call it snail drop or spiral cam. So it looks like a snail and then it rises and drops. That's why it's called drop cam. Again, the followers, after classifying cams, followers, you can also classify cams followers in different types. The 3 different types we're going to study are based on their shape. So these are the followers. So these the lower end. These are cams, but these are the followers. So if you see, this has a roller follower. The follower has a sharp edge. That's why it's called point head. That's why it's called knife edge follower. And if your follower has a flat head, then we'll call it flat follower. So before we jump into our main goal, developing the displacement profile for cams, we need to learn the terms that we use for cam systems. The first one is dwell. It is the time or angle over which the follower displacement doesn't change even though the cam is turning. So remember from our definition, the cam mechanism converts rotary motion to linear motion. And while it is doing that, there will be a position where the cam is rotating, but the follower is not having a displacement. That is the dwell time. And we'll see examples really soon. Then it comes the rise. It is the time period or angle over which the cam pushes the follower. So again, the displacement, the time over the cam pushing the follower is the rise. And if it's a reciprocating motion, so when there is a rise, there will be a fall. So the opposite time when the cam is moving, turning, and the follower is coming back, it is called the fall. So now let's look how these terms applies to our 4 different types of cam mechanism. So the first one that we're gonna study is the pier cam mechanism. It is called pier cam because it has a pier shape, and you see it is circular on one side and kind of oval on other side. So when it is on the circular side, if we start a 0 degree from the middle of the circular side, so you see when the circular side is hitting the roller, it is not pushing upward, only the oval part is pushing it upward and downward. So that's why we'll have dwell time at the beginning and also dwell time at the end, and in the middle you will have rise and fall. If this edge, the oval edge, is not sharp and it also have a circular portion, then you may still have a brief dwell time at the very point here, but sometimes you may not have that if the point is sharp. So pier cam produces this sinusoidal rise and return here, and we can use roller, knife edge, or the flat head follower with this one. We can also apply either direction of rotation for pier cam, and it will create the same displacement profile. The second cam mechanism we're gonna study is the offset circular cam. The cam is circular and it is not rotating about its center, it's a little offset, and due to the offset, it is pushing it upward and downward. If it was if it was rotating from the center, it would not have moved the follower. And due to this offset, it is going rising and falling, and there could be a very brief dwell time based on the location of your the point of rotation or not, but mostly it is rising and falling over the angle. And we can use this cam mechanism in both direction, counterclockwise or clockwise, and we can use all 3 types, flat or roller or knife edge follower with this one, but roller cam will work more accurately with this type of offset circular cam mechanism. So our third mechanism is the hard cam mechanism. It also creates a symmetrical profile rise and fall. There is no dual time for this. It can rotate counterclockwise or clockwise. Either way, it will create this symmetric rise fall displacement profile. We can use the knife edge follower, roller, or flathead follower, but the knife edge will give you the more accurate um, representation of the cam. So our fourth and last cam mechanism is the drop cam mechanism. It is also called snail drop or spiral mechanism. It is based on Archimedes logarithmic spiral that gives a triangular non-symmetric profile when you use the cam mechanism. It linearly increases and then suddenly drops. It has no dual period, and it can only work correctly if we use the knife edge follower. And one thing to notice, for the other three, it can rotate. We can have it function rotating both direction, clockwise or counterclockwise, but the drop cam only works in only one direction. The other direction, it will not work.